Hey, this is the video for 1.1, Subatomic Particles. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Check out the essential vocabulary. Today we will be discussing the gold foil experiment, subatomic particle, nucleus, proton, neutron, and electron. So throughout history, there's been many different views on what an atom is. And an atom is simply the smallest unit of an element. And initially, they thought the element or the atom was a hard little sphere, and this is considered the Dalton atom. Basically, a round little sphere that cannot be broken down. Through scientific discoveries, we've discovered that there are more components to an atom. And that led to the Thomson view of the atom. And the Thomson model is also called the plum pudding model. Plum pudding, basically like you have your pudding and then you have your little bits of fruit inside there. Also like Jello, you might have fruits in a Jello mold. And basically you have this positive matrix that has these little negative embedded areas inside them. And further study revealed more detail within the atom. And a scientist by the name of Ernest Rutherford performed a gold foil experiment. Basically a really thin sheet, but basically only a couple of atoms thick, very thin sheet of gold foil, and he shot these alpha particles through. And alpha particles are just 2 protons and 2 neutrons. And he shot them through, and most of the particles went all the way through, as you see in this animation. Some of the particles bounced back at him. So that means they must have hit something. And this is how they discovered the nucleus of an atom. So basically this is a diagram, what it would look like from the side. This would represent the gold foil. Most of the alpha particles went straight through, and some of the alpha particles were either deflected or bounced back. So what happened in the gold foil experiment is alpha particles were shot at a thin sheet of gold foil. Now the observations were that most of them went through. The conclusion that can be drawn from that is that the atoms are mostly empty space. But some of the alpha particles bounced back, and the conclusion that was drawn from that is that this was a very dense and a positively charged nucleus. One thing I want you to do is definitely take note of this. Whenever you see a purple box with purple text inside, you should absolutely copy that in your notes in addition to other information. Now, Ernest Rutherford determined that we have subatomic particles. And there are 3 subatomic particles. A subatomic particle, there are protons, neutrons, and electrons. So as you look at your periodic table, this is found in the reference table, you will see information that is valuable to us. So for starters, we have a nucleus. The nucleus is the center part of the atom. It is a positively charged center of the atom. It contains protons and neutrons. In this color scheme, red would represent the protons, white would represent the neutrons. And the charge of the nucleus is the same as the number of protons. In this helium atom, the charge of the nucleus is equal to +2. Now, a proton is a positively charged subatomic particle. It has a charge of +1. It is found in the nucleus. The number of protons is equal to the atomic number. The atomic number is this number right here. Look at the key in your reference table and you will see that is the atomic number. And the mass is 1 atomic mass unit. That's just an arbitrary number. A mass unit is roughly the size of a proton and a neutron. We now have a neutron. And a neutron is a neutral or has no charge. It is a subatomic particle in the nucleus. It also has a mass of 1 atomic mass unit. In order to determine the number of neutrons, what you do is you take this number, which is the atomic mass, we'll talk about it later, and you take the atomic mass minus the number of protons, and that will give you the number of neutrons. Now don't worry about these decimal places. Round this atomic mass to the nearest whole number, subtract the number of protons, and that will give you the number of neutrons. We will discuss why this looks like a decimal later on. And finally we have an electron. And electrons are negatively charged. They have a negative charge of -1, and it is a subatomic particle in orbitals. And we'll discuss orbitals in the future. It is equal to the proton. The number of electrons is equal to the number of protons in a neutral atom. So in this atom of helium, you have 2 electrons. And it is so small, the mass is so small, it is 1/2000th of an atomic mass unit. In other words, the mass is negligible for an electron. It's kind of like when you go to the doctor and if you're wearing a watch, for example, and you're getting weighed on the scale, they don't ask you to take off your watch because the mass of the watch is negligible. Now, this is just a visual representation of the subatomic particle mass. We have a proton, we have a neutron. They are roughly the same mass. We have a proton and electron. The proton is much heavier than an electron. And we have a neutron and an electron. The neutrons are much heavier than the electrons. In fact, these are 2,000 times heavier. These are 2,000 times lighter. So what I would like you to do is respond to this check for understanding. I would like to ensure that you understood what I was talking about in this video. I hope that this video was informative. I thank you for your attention, and I will see you soon.